Hey guys, and in our previous session we just seen about that double integration method and what is the procedure they are using. We know that moment can be calculated, and because of the load there is some radius has been created, that is what do you call that radius of curvature. We need to use this basic equation m is equal to E into I d square y by dx square. With the help of this equation we are going to find out what is the deflection value. Okay, so that is what exactly that we are going to do. Okay, here the bending moment m is equal to E into I, where E represents it is the Young's modulus and I represents it is the moment of inertia. And that 1 by rho is also called it as a curvature. It is about the radius of curvature. Here an expression of the curvature at any point along the curve representing the deformed beam is readily available from differential calculus. The exact formula for the curvature which has been calculated here, the dy by dx, that is the deflection value is very less, that slope value is very less. Okay, hence we need to omit that dy by dx is as an smaller value, and based upon that we can decide that radius of curvature will be very small in this equation. So that is why we need to integrate one hello. So here that we need to take the bending moment equation in two different categories. One is called integrating the ones we are going to find there is a small slope is there. Okay, so whenever the load has been acted over the beam, that deflection will create some amount of slope. That slope we need to integrate starting from 0 to maximum infinite position. That is why we have to integrate their equation while finding the bending moment. So that is why it is a very important. And integrating the twice, which can yields to the deflection wherever the deflection level has been increased, and the bending moment m must be expressed as the function of coordinate with respect to the x, that x represents with respect to the x-axis the deflection will make a moment. Okay, the differential equation is second order. That solution must contain two constants of integration. They must be evaluated at the known deflection level, and the slope points that can if you're going to build at a beam, this beam can vary with respect to the slope and the load. It can deflected from each other points. So that is why we have to analyze with the help of this slope moment equation. Okay, so let me see in detail about this bending. So generally we know that in our previous lectures we studied about the bending moment diagram and the shear force diagram. So there is a shagging and there is a hogging. Shagging means if a beam deflected towards upward direction, it is called the shagging. In simple words, we use to say it is the positive bending moment. Suppose if the beam gets deflected, or if the beam gets bended towards the downward direction, this is what do you call that hogging moment. This is what do you call that negative bending. Okay, so this can be represented these two different curves which has been mentioned as a positive bending and a negative bending. So generally we know that there is some assumptions and also some limitations in this bending moment taken place. The first one, deflection caused by shearing action which can be negligibly small. Okay, so because of the deflection, the shearing action which can be negligibly small as compared to the bending. Okay, so that is the first deflection caused by shearing action which is negligibly small compared to the bending. That is an assumption. Deflections are small compared to the cross-sectional dimensions of the beam. Deflections are small compared to the cross-sections of the beam. Okay, cross-sectional dimensions. And the third one, all portion of the beam are acting in elastic range. All portion of the beam are acting in the elastic range. And the fourth one, beam is straight prior to the application of the loads. Beam is straight prior to the application of the loads. Okay, based upon these four assumptions we can analyze their moment of the bending, and along with this category we are going to check about the beam deflection. So that is what we are primarily focusing on it. Okay, we can, in our upcoming session we will check in detail about this beam deflection.